Hi folks, welcome to a new video. So in the last video we discussed about the basic statistical metrics that we would be using to measure performance and compare methods and stuff. In this video I'm mostly going to go through some distributions that we might come across, the most common ones, let's say. So we have these four kind of distribution. One is normal distribution. It's like the ideal use case where everything is like happy and merry and go and whatever you call it, right? So there's the normal distribution. Then we have positively skewed. If you can see, some values are pulling the distribution towards this direction, and negatively skewed is the opposite. Some values are pulling towards that direction. And then we have outliers. Outliers is like, if you see, this is a normal distribution, but there are some values towards the end which are sort of extending the curve, so it pushes the mean towards this direction, if you can visualize it a bit, right? So but yeah, that's what. So what is a normal distribution? A normal distribution is basically, let's say you can take an example of, if we try to calculate, if we try to build a distribution of, let's say, the height of the people in a region or something, right? So that won't vary much, as in like the deviation would be sort of similar. We would have some would be taller, we would have some would be shorter, and this will be the sort of a distribution that we would likely have, right? So this is just an example of what distribution might look like for a normal distribution. Like everyone grows, like someone is born, they grow, the height increases, and after a point it stops, and like it's a very predictable behavior, right? So you can sort of say that normal distribution follows some kind of rules without like outliers and without edge cases and whatever stuff, right? So it's a predictable path. You can like, not exactly, but you can intuitively think of it that way, right? So then we have positively skewed distribution. Positively skewed distribution could be what to say. Positively skewed distribution is basically the mean and the median aren't the same, so there is some difference between both. So there are some values that are like pushing in mean away from the median here, if you may think of it that way, and you can think the other way as well, like pushing the mean away from the median or pushing the median away from the mean, doesn't matter. So basically so there are some values which would cause this to happen, and the standard deviation again is like how it would vary based on whatever input we have, right? So this can be, let's say, the average income of a country or something, right? So here basically, if you assume the middle income range, that won't be very much affected by the ones that earn more, but and a significant amount of data, like the high earners would have a significant amount of influence on the distribution that takes place, right? So it's not very confined, or as in like, if it's like, it's very it's very how do I say it, it's very collected in a particular region and spreads around, like for the others it's not that collected. So it's a good example of the income in like developing countries as such, right? So majority of the wealth is owned by a few people, and then it gets like it's sort of goes down as we take into account more and more people, right? So that's a positively skewed distribution. A negatively skewed distribution can be, let's say, for example, the retirement of people, right? So let's take an example of that. So for most cases, people just start a job right after their college, so that's something we can predict. But many people retire early. So many people do their job till 60s, many people retire early. So there is like that difference in the data, which causes the data to be negatively skewed, right? So the people who retire early tend to change the value or tend to pull the mean from the median or like whatever, right? So it's more distributed towards the end side of it. That's the negatively skewed distribution. And we have outliers. So for this, a good example would be, let's say, grading in classes and stuff, right? So if you have this, there will be people who would have predictable grades, there will be some A's and all, but there will also be people who would fail the exams. What that data set would end up doing is, it will sort of create a normal distribution for a subset of the data, but the rest of the data will sort of push the normal distribution towards the beginning, as you can see here. So these are the outliers, as we call them, right? So in an example of classroom, we can like take the people who fail the exams as the outliers, just for an example's sake. So yeah, that's how we can sort of visualize the whole thing. And here you can compare the mean values. Let's say for normal distribution, the mean, median, standard deviation. Mean, median are almost same. The standard deviation is sort of here it's 9 or something. So like it basically tells, as I said, how the output might vary based on the input. One metric that affects standard deviation much is, you can see the outliers, right? In the outliers, it's the same as this, but the standard deviation is a lot more. So if the mean and median are almost same, but the standard deviation is a lot more, you can think that it's sort of a long curve that is extended, but much of those are sort of normally distributed in a subset of the data set. So the point I'm trying to make is basically, when you see these values, you should be able to sort of visualize the curve, right? So if you see these kind of values, you should be able to instantly tell, oh, okay, here are some outliers in this distribution. If you see these values, you should be able to, okay, this is a normal distribution, and like so on, right? So that's what, if not exactly, at least like try to form an intuition around it. So yeah, that should be it for this video, I think. If you found it helpful, maybe drop a like. If you have any suggestions, drop a comment. If you want me to make videos on something else, you can suggest, of course, and maybe share to your friends, and of course subscribe for more. And yeah, in the next video, I'll maybe get started with our first like actual comparison, where we write the code and we plot the graphs and we start comparing and run the benchmarks. And yeah, that should be it for this video, folks. See ya, guys. Bye.